Okay, good afternoon, everyone. So, dear authors and invited guests, welcome to the technical session 4B. I'm Riddhi Gohel, moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 7th International Conference on Smart Trend in Computing and Communication through Zoom. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 8 presentation and each presenter will be given 8 minutes for the presentation and the 2 minutes for the question answer. On 7 minutes, I will raise a gentle reminder to conclude your presentation. So kindly be on a time limit. There is another request to all the participants that you all stay connected with us till the closing remarks. Just before we get started, I would like to introduce to all our chair of the session, Professor Rajan Patel. So, Dr. Rajan Patel is a professor in the Department of Computer Engineering at Gandhinagar Institute of Technology and the Dean of Department Engineering Technology, Gandhinagar. He has a more than 17 years of teaching in the field of computer science and engineering. He has a more than 56 collaborative publications in journals and conference and presented 17 articles in national and international conference including IEEE, Science Direct, Springer and elsewhere. So we welcome you, sir. So just I would like to invite our first presenter. P.G. Patil, and the paper title is A Review of Depressive Disorder Detection Based on Sentiment Analysis.
Is my screen visible, ma'am? Okay, shall I
Yes,
start?
yes, sure.
Okay. Good afternoon, one and all present here. I'm Chaitali Patil, presenting a topic on a review of depressive disorder detection model based on the sentiment analysis. So, a computer vision ways of emotion recognition, like from the facial ecological signals form. So we consider the social media platform for depressive disorder detection, and the emotions are broadly categorized as love, joy, rage, sad, fear, and surprise. So therefore, there is a need of an emotional health detecting system which can detect the user with potential psychological disturbances. So this is the diagram. Actually, this diagram is get divided into the two part. First, left hand side part represent the method. So different types of method through which we can find out the depression, and the right hand side part shows the domains where we can collect the data. So basically, there is a reason behind to select this topic is actually I gone through one video of Swami Mukundananda, and he described about the neuroplasticity, which explain whatever we think repeatedly, we are contemplated in this action. So there is an objective which I want to achieve in this topic. So the objective is that the depression is a common but the serious mood disorder, and the objective of this research is to develop the system for the early detection of the depressive disorder among the social media users. So this is the literature survey. I have gone through this literature survey. Of convolutional layer should be improved the accuracy, but also in the cross tab. So we can can give the optimistic solution with the better time complexity and acceptable accuracy. Next is the redundant feature may generate high false positive ratio in the classification, and many researchers have done the image sentiment classification using the CNN and deep learning. But still, those systems are facing issues like accuracy of detection and the time complexity also. So all these are features which is considered by the previous authors, like age, gender, time, engagement, egocentric social graph, network property, linguistic style, and the hashtag. All these are the feature extraction techniques which considered by the previous author, like TF-IDF, bag of words, linguistic inquiry and the word count, word to vec, n-grams, word to sequence, tokenization, glow, post vector, and the fast text. All these are the different techniques which used by the previous user, that is navy bias, random forest, svm, cnn, lstm. But it is observed that cnn can only extract the very small type of information, while whereas lstm may overcome this constraint. So the cnn lstm architecture combines the cnn layers for future extraction on input data with lstm to facilitate the sequence predictions. So we can say that lstm is the better technique to find out the depressed people. So all these are the references which I used. Thank you.
Okay, thank you, Chaitali, for the presentation. So next presenter is Variender Kaur, and the paper title is A Systematic Review, Imbalance Network Traffic Classification Using Machine Learning Techniques.
My topic is a systematic review, imbalanced network traffic classification using machine learning technique. These are contents: abstract, introduction, literature review, review methodology, and conclusion. The major purpose of techniques of classifying the traffic in network is to identify various type of system or traffic data. The analysis of received data packet is performed due to its necessity in communication network nowadays. There are diverse ways to classify the network traffic, such as to pre-process the data, extract the attributes, and perform the classification. The data set is utilized for the input in the classification stage. This paper studies diverse machine learning techniques in order to classify the network traffic. Traffic classification is an automated process which categorizes computer network traffic according to number of traffic classes. As we know, it is very essential task for internet service provider to know which type of network application flow in a network. Network traffic classification is first step to analyze and identify different type of applications flowing in a network. Using network classification technique, internet service providers can manage the overall performance of a network. There are many ways to classify internet traffic, like pod-based, payload-based, and machine learning-based technique. I review on just machine learning-based techniques. All the tasks carried out in network traffic classification model, the steps are: first is data collection. In this step, the real-time network traffic is captured. There are many tools for network traffic capturing: TCP dump tool, Wireshark tool for capturing, packet capturing and analyzing. Second is feature extraction, and selection. In this step, the features are extracted from the captured data such as packet duration, packet length, inter-arrival packet time protocol, etc. Next step is implementation, feature reduction, and implementation of machine learning algorithms. In feature reduction step, it is utilized to generate the novel attributes for which the original attributes are employed. On the other hand, the technique of selecting attributes is adopted to investigate a reduced set of attributes. And next step is implementation of machine learning algorithms. This is the implementation step, which include applying machine learning algorithm or classifiers on the instances. Next step is result and observation. After the implementation of machine learning algorithm, the simulation tool gives detailed result about the applied algorithms such as accuracy, F1 score, precision, and recall. It is a figure of network traffic classification steps. During the network traffic classification, there is a problem arise of a class imbalance, which can be solved by using class imbalance approaches. There are two types of classes during class imbalance problem. The class with the greatest sample dimension is known as majority class, and the class with the smallest sample dimension is respectively known as minority class. The problem of class imbalance has two main categories. First is internal imbalance and second is external imbalance. In internal imbalance is normally due to existing the data frequencies, and external imbalance is the result of external factors. The approaches used for solving the problem class imbalances are data level methods, algorithm level methods, cost sensitive methods, hybrid methods. The data level technique deal with the class imbalance by oversampling and undersampling respectively, by enlarging the sample size of minority class or reducing the sample number of minority class. Next is algorithm level method. Its learning or decision process is adjusted to maximize the efficiency of the positive class. And next is cost sensitive method. In this technique, the data level transformation are integrated with the algorithm level variation. The cost related to them is classifying samples are taken into account using the cost metrics. Next is hybrid. The integration of data level is done with the algorithm level techniques in several ways and deployed for dealing with the class imbalance issues. Here is a literature review.
Yes, ma'am, sorry for the interruption.
Yes, ma'am.
Yeah, you have only 1 minute left.
Hello?
For your presentation.
Okay, ma'am. So the review methodology is development of review protocol and source of information. For review study, various electronic database sources were investigated. Database from electronic use Google, Ville, Elsevier, Springer, IEEE, ACM. inclusion and exclusion criteria uses keywords such as network traffic detection, machine learning algorithm detection for network traffic detection, the outcome extraction. The I took conferences paper 51
Hello,
40%
madam.
and 9% book chapters, and I studied journals 51%.
Madam,
Three kind. Yes, sir.
I have a question relevant to your title. That means
Yes, sir.
you are nothing. You are classifying the network traffic, right? So
Yes,
as
sir.
you mentioned, there are lots many methods involved for the network traffic classifications, right?
Yes, sir.
So
Yes, sir.
what I uh, insist you, these are the. I mean, here you are displaying, showing us your research methodology, na?
Yes, sir.
So that is the way you approach and to find out the way how to classify the traffics, right? So at this moment, instead of showing your methodology, right? So obviously all
Yes.
people are doing the referring the research papers and reviewing the literatures, right? And they are finding
Yes.
something insight from them, right?
Yes,
That's
sir. Yes,
fine.
sir.
So that is not a part of our technical or say manuscripts.
Okay, sir. Sir,
Do you
but
got my
it's
point?
a review methodology.
Yes, fine. You did a review from the many of the good reputed journals or say publishers also, right? So like
Yes, sir.
Elsewhere's, right? And
Yes.
Google Scholars. Google Scholars, that is not a publishers, right?
Okay, sir.
So apart from there are many other publishers are there. I mean, well-known good publishers are there, even though IEEE, Science Direct, Hindwai, IGI, right? Lots
Yes,
many
sir.
are there. Right?
Yes, sir.
And these all the references part of that you are already included in your list of references, right? So
Yes, sir.
we know that's fine, right? And over
Yes.
and about that, I have one comments. You just go to the slide number 14 or 15.
Okay, sir.
Yes, right. See here,
Yes,
what
sir.
you are highlighting, the name of the authors, right? The year of
Yes, sir.
publications, right? After that, the
Yes.
method they utilize. I mean, they use the methods in for
Yes,
which
sir.
particular types of the simulators or say tools they were used, right? And then
Yes,
after
sir.
your
Yes.
remarks, right? So
Yes, sir.
in this
Yes, sir.
case, what you can do, this is the review things, right? So what we can do it. Uh, we can split the tables also, and you can provide the detailed review also, right?
Okay, sir. Okay, sir. I got.
This is my suggestion that can be extended in. So
Okay.
somebody, if as a layman person, what I'll do,
Yes, sir.
I'll look your paper and then I read your paper, so I
Okay.
can got every detail in the sense of how many ways for the network traffic classifications, how the
Yes,
people
sir.
are classifying, what are the
Yes, sir.
method involved, what are the techniques involved, right? What are the
Yes, sir.
tools involved, like that way, right?
Okay, sir.
Okay,
I got
okay,
it,
ma'am.
sir. Thank you for suggestion, sir.
Okay,
Thank
ma'am.
you.
Welcome.
Okay, thank you, Varinder.
Okay, ma'am.
So we are moving our next presenter, and she's Renuka Deshmukh. And paper title is a digital infrastructure and application for smart cities and social societies. Role of artificial intelligence.
Yeah. Thank you, ma'am, for this opportunity. So I'll just share my screen.
Yes, ma'am.
So, good afternoon, all respected panel members. So the title is Digital Infrastructure and Applications for Smart Cities and Societies, the Role of Artificial Intelligence. So in this paper, we have tried to understand the applications of AI in smart cities. Wherever they are applied, we try to understand the important significance of the same by collecting primary data. So we have collected primary data of some multinational corporations and And we have also collected primary data from major domains of the society, where which we considered these are the major domains of society wherein AI applications can be made. So to start with the presentation, so introduction. So as we all know, many people have now shifted to urban areas. So a city is identified as a densely populated area. It is a permanent and heavily populated region with officially defined limits, with members primarily engaged in non-agricultural tasks. So this is one of the way a city is defined by one of the author, which we have cited in our paper. So the rate of urbanization, which is increasing, will have a significant influence on the environmental management, healthcare, energy, education, and security of the cities. So smart cities will then become the standard in the country's major urban areas. So modern smart cities use various technologies and support advancements that can assist cities in achieving long-term socio-economic goals and prospects. A diversity of smart city projects is being implemented across diverse geographical places as it is evidenced by many studies. So we have done a vast literature review. We have tried to study various research papers related to this, and based on that, then we have come to some conclusions. So in that, we have tried to cover different definitions of the smart city by various authors. Then the role of technology, which plays a crucial role in smart cities, and creative technological techniques effectively assist cities in becoming smarter. So smart cities use ICT in and to automate processes and improve the quality of people's lives in urban regions, as we all know. So moreover, it employs integrated intelligence technologies to improve municipal infrastructure and enable responsive governance to involve inhabitants in city administration. So the two major technologies which were found in our data collection were artificial intelligence and IoT. Then we have tried to understand AI in the smart city. So we just came to few parameters like where AI is applied, so and where it is used. So it was especially used for smart mobility, smart governance, smart economy, smart education, smart living, smart environment, and smart healthcare. So these were the major domains where we found that mostly it is applicable. So smart mobility, so in traffic management, or like the involvements were majorly in traffic management, autonomous and sustainable mobility, supply chain resiliency, smart routing and parking. Then in education sector, it was smart classroom, virtual reality based learning platforms, student tracking management, learning tools for special needs students, and smart library also was there. Then in healthcare, one next was healthcare sector. So in that, smart hospitals, telemedicine, telenursing, then smart healthcare tracking, e-health record, patient monitoring, pandemic predictions, and also we have tried to covered in the paper. In environmental related, AI applications were majorly found in air quality monitoring, weather monitoring, waste management, water management, smart irrigation, photovoltaics. And then governance also we found majorly these tools were used, technology was used like in e-governance, decision making policies, disaster prevention and management, urban planning. Then living and infrastructure sector. Next was living and infrastructure sector. In that, smart building, smart home, smart education, smart tourism, smart policing. So these were the major parameters we focused on and emphasized. Then in economy, for growing, for maybe developing the economy, smart businesses, e-commerce, retail, smart shopping, peer-to-peer marketplaces, peer-to-peer labor services, smart supply chains, smart sharing services. So these were the few parameters we have highlighted from each sector where AI application was mostly used and applied. Then also we have tried to understand through the literature review some cities and nations, top 10 nations where it is mostly used. So we found that it was mostly used. Number one in ranking was Singapore and Zurich. So this was we understood through one of the literature review research paper. Then next we also tried to find out its application, IoT applications in smart modern cities. So while doing the literature review, we focused majorly on artificial intelligence and we also tried to understand the domain sectors as just now I have mentioned. In agriculture also it was found majorly was used. Then to come to the conclusion part, I guess the slides are not moving. So these are the major domains of smart city, integration of AI in smart healthcare. Healthcare especially it was used on a large scale. So we have concluded from the data collection that cities have changed dramatically due to the invention and implementation of multiple concepts such as resilient cities, sustainable cities, and inclusive cities. To name a few, AI and IoT are two important technologies that have the potential to turn cities into sustainable smart cities. So the basic conclusions which we came upon were that cities can benefit from incorporating AI into smart cities by automating operations, reducing human error, making effective data-driven decisions, improving the environment through different systems, implementing new commercial possibilities, and automating efficient urban management. On the other hand, they also pose regulatory challenges. So many challenges were also discussed by the participants, so such as discrimination in service delivery, privacy, legal and ethical considerations. Furthermore, data availability, lack of qualified professionals, cost and duration of AI initiatives, and high unemployment rate have all been recognized as risks and barriers to AI implementation in smart cities. Healthcare was the first topmost, where 23% was mostly these technologies were used. Then mobility, privacy, security, energy. Okay, sectors have a great impact on AI adoption in smart cities, according to our findings. The healthcare sector has increased its AI-based breakthroughs by 60% since the outbreak reached cities in 2019. So because of the pandemic also, this influence was there. Then AI algorithms such as these were the few algorithms which we have found in the through the literature review that have a great influence on the various smart city sectors according to the analysis. So thank you, sir. Thank you, ma'am. That's all from my side.
Hello.
Yes, sir. Yes.
Yes, ma'am. The work is okay, fine. Here you are. I mean, you are highlighting the role of AI
Hello, good.
Yes,
in
sir.
the digital infrastructure. Right?
Yes. Sir.
So here, what you can do, you can provide the more technical specifications or details also relevant to
Ah,
that one.
yes, sir.
Whatever you presented, that is relevant to the theoretical point of view backgrounds. But
Yes, sir.
in that case, you can add on more detailing.
Ah,
The AI now AI it's not only sufficient in the sense that
ah,
further the AI it's a subsets of. There are many other
ah.
subsets for the
Yes.
data means machine learning or say deep learning, right?
Yes, sir. Ah, ah.
Okay.
Yes, sir. Yeah,
The rest of things,
definitely.
okay, fine. Yeah,
Thank
thank
you,
you.
sir, so much. I will try to incorporate that now in my further research. Thank you for the suggestions. Sir.
Thank you, Renuka ma'am, for the presentation.
Thank you, ma'am. Yeah.
Yeah. So our next presenter is S. Lohita, and the paper title is a fake news detection using machine learning.
Yeah, ma'am. Good afternoon, ma'am.
Yeah, good afternoon.
Good afternoon, ma'am. Our project is fake news detection using machine learning. Project statement is news spread rapidly among millions of users within short span. So we aim to perform binary classification of various news articles and online with the help of concepts pertaining to AI, NLP, and machine learning. We aim to provide the user with the ability to classify the news as fake or real. Uh, these objectives are we can decrease the spreading of fake news and prevent the false crisis events, and we can get awareness among people without blindly following the news. Because there are many news which spread within short span of time, but we don't know whether it is fake or not. By using a project, we can classify whether the news is fake or real. Uh, and our model is that we can recognize the faces of a person in both the front element and also view image. Architecture diagram of the project is we used a Kaggle dataset. After data scraping, we have used data collection. After performing data collection, we have performed data cleaning, and then we have extracted the features from the dataset. Um, After feature selection, we have trained the data and half of the test data. After training the data, we have used ensemble method in order to get the greater accuracy and performs. Yeah. After using the test data, we have evaluated the model. Uh, Procedure. Uh, we have loaded the dataset from the Google Colab. We have given the class labels as 1 and 0, 1 for fake news and 0 for real news, combining two datasets into one dataset and cleaning the dataset after extracting the features which are useful for our project. And we have 100% data and 70% for training and 30% for testing. After performing, we have applied decision tree, random forest, and logistic regression for the news, I mean dataset. After that, we have calculated the accuracy of the model, performing whether the news is fake or not. The algorithms we have used is a decision tree, random forest, and logistic regression. Dataset description, we have taken the dataset layer dataset from the Kaggle, which contains 23,481 columns of fake tweets and 21,041 columns of real articles, and 30% of data is used for training, 70% for testing. We have title, text, subject, date, class as columns. Results of the project is we have given the input some string, and the manual testing is performed on that news. We have predicted that it is not a fake news. And here is one more example. We have performed manual testing on this description. See, as generally social media continues to gain popularity because most of the people choose it as a primary news or else to get know about the news, what's going in the society. Uh, and even the social media has misleading information which diverts the people minds, whether it is fake or else it is real, which harms both consumers and society as a whole. In this research, we examined the issue of fake news by defining and identifying in the literature. We outlined the main ideas and principles of misleading news in traditional and social media during the characteristic phase. We looked at existing feature extraction and model building techniques for detecting fake news in the detection phase from data mining perspective. We also expanded the topic to include additional applications and looked at data sets, evaluation criteria, and possibly fresh approaches to study on false news identification. That's it. And these are the references we have used for our project.
Yeah, thank you, Lohita, for the presentation. And just one announcement for the Jai Sakti. Hello, Jai Sakti. Can you hear me?
Yes, ma'am.
Ma'am, you are actually belong to virtual session 4A. This is the virtual room 4B.
Okay. Should I move over there?
Sorry, ma'am.
Should I move over there?
Yes, ma'am. Yes, ma'am.
Okay, ma'am. Thank you.
Yeah. So our next presenter is Prem Lata P. And the paper title is IoT based on non-invasive glucometer.
Yeah, yes, ma'am. Just wait a minute.
Okay.
Ma'am, now it's visible?
Yes, ma'am, it is visible.
Yeah. So I'm Premlata. I'm going to present IoT based on non-invasive glucometer. So the aim of this project is to develop the portable kit for diabetes patients. By using the kit, diabetes patients can take it along with them and anywhere, and it's a non-invasive method, and the patients can measure at any time the sugar level. So this is the introductions of my project. Diabetes is named as the most important contributor to any form of the major disease, and based on that, it will cause somewhat complexity and health issues like hyperglycemia, type 1 diabetes and type 2 diabetes, like this way. So this disease occurs when the glucose level within the blood increase above the threshold value. So therefore, regulate determinations of blood sugar level could be the condition to take care of the diabetes patients. That's what we are introducing, the non-invasive technique. Without taking the blood outside from the blood, we just detect what is the exact sugar level of the patient's body. So in this thing, we are using the infrared LED light and photo detector, passing the finger and get the exact concentrations of the sugar glucose level within the blood, and it's automatically catered by the scattering and absorption of infrared emissions through the blood. So this thing is the amount of the concentration is displayed on the LCD. That is the final output. Okay, and in middle of the thing, to start the process, insert the fingertip in between the NIR LED and NIR PD. So the reflected signal is fetched by the NIR PD. So this one is give the exact value how much of the glucose is traveling, how much of glucose presence in our blood, patient's blood. So objectives of this project: to combine the different health monitors into the single manageable device, and to design a non-invasive glucometer to measure the blood glucose level in our body, to design and develop stimulation model using NAO technique based glucometer, and to measure and analyze the blood glucose level in our body, and same thing to minimize the invasive type devices, to design and develop blood measurement techniques based on infrared using a non-invasive method. So these are the components we are using in this project. So very first one, ESP8266. This one is on microcontroller. This one is low power, highly integrated Wi-Fi microcontroller. So this one is minimum of 7 external components are required. The temperature level is minus 40 degrees Celsius to 125 degrees Celsius is the wide temperature range. This Wi-Fi models are distinguished by the high level of integration and reliability to the embedded ESP8266. And next one, LM7805 voltage regulator. So most of the projects we are using, this type of IC, we are using the wide range of projects. These things have the 3 pins. First one, positive pin, it's giving the unregulated positive voltage is provided, and ground pin, it's giving the neutral for input and output. And VO output voltage, this one is the regulator. It's used to extract the regulator 5 voltage level. And next one, IR LED. So IR infrared LED is a diode or simple semiconductor. This diodes permit electrical current to pass in one direction. So as the current run, the electrons go from one portion of the diode to another part. Where they fall into the holes, the enter this holes, electron must release the energy in the form of photons. So automatically it emits the infrared range. Infrared rays with the wavelength ranging from 700 nm to 1 nm. And next one, photodiode. So photodiode, it's a contrast to the LED. So this is the type of diode. Each one does not emit light but can detect its presence. So this one allows some current to flow through it after detecting the light, and the amount of current flow is directly proportional to the amount of light detected. And next one, LCD. So LCD, it's a contrast regulator. It's used to changing the contrast of the letter pixel display on the LCD. So it has the separate LED positive and LED negative, and also having the eight data pins in LCD. So it's used to display the sensor reading or visualizing the values. What they has been processed in the program. And next one, 12C serial interface adapter. So this one is used to decreasing the wiring in the circuit connection, and also it will make the circuit connection made as the simple. So this one is this one is transferring the data from one place to another place, and it's also used to carrying the clock signal. So these are the important components we are using in the non-invasive method by detecting the diabetes glucose level in our blood. And this is the block diagram. So in this block diagram, we are using as usual microcontroller and amplifier and LCD display, and finally we are using the cloud computing to transferring this information to the mobiles or computers to visible, getting the digital wise output also. And same thing, this data is also stored in the mobile or any pen drives or like this way. This is the block diagram for this thing. And the methodology, this one is, so how to measure the blood glucose level in the body means by using the non-invasive method. Here NIR LEDs, NIR means near infrared LED, and NIR photodiode determines the concentration of blood glucose level. So this blood glucose level is calculated based on the scattering and absorption of infrared light through the blood. So this level of blood glucose will be displayed on the LCD in the appropriate unit. So these things, the final output, the doctors want to, the patients want to record it, or we just want to save in a particular pen drive or any disk. So you have to transferring from by using the cloud computing systems, and finally you get the data in the final thing. Okay, so this will be processed the data, and blood glucose values will be displayed in the LCDs. Okay, and this is the results. How this one is data, how it's calculating the blood sugars values in the blood. So this one is the result, and this one is data sent to the cloud computing method, and this is practically be taken, and this is where so this is the kit for blood glucose monitoring. And conclusion, we designed and implemented the non-invasive glucometer to determine the blood glucose level concentration. That levels also we just transferred and stored in the some data. If required means we have to, because the patients want to take morning itself and afternoon, and means that time we just going to compare the data. Means that time you have to move to the hard disk or pen drive. You have to keep the data permanently. So in future, we try to more accuracy. Glucose level was analyzed and results was obtained successfully with the cloud through the IoT based systems. These are the reference. Thank you.
Madam.
Yeah, yes, sir.
Is it not IoT based application?
Sorry, sir.
Is it not IoT?
It's IoT only, sir.
Yes. So in future, what do you want? You want to improve the accuracy of your system, na?
Yes, sir.
Okay. So what are the way? How will you improve the accuracy?
Accuracy, instead of we just reduce the we just going to change the microcontroller, a little bit electronic components, little bit alterations, instead of interface adapter, we just move to the another steps, sir. And same thing in future we also plan to
see here. You mentioned the accuracy of your system, that is 75 to 80%.
Yeah.
How will you, how did you measure that accuracy with
the like this way? So once again I will show, sir.
number of input samples.
Yeah, number of input samples, and we just compare the manual part and this kit
Okay.
also, sir.
Fine, good. Now, what I'm suggesting you see,
Yeah.
if you wish to improve the accuracy, so accuracy that is purely rely on your device in this in the sense of sensors, right? Then
Okay.
later on, our job is what? Later on, our in IoT system job is what? Simply we have to improve the latency.
Okay.
Right?
Okay.
So that will be gives you response in real time. For
Okay.
that,
Okay.
at application layer, you can use the many of the protocols like CoAP, 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 then MQTT, that is message queuing telemetry transfer protocols, right? So that will be allows, I mean, that will be helpful you to improve the accuracy. Accuracy, I can't say accuracy, but that will be improve the response time.
Okay.
Right?
Okay. Okay, sir. Okay.
And
Okay, sir.
depends on the way you are using the cloud service, what type of the service you are using, right?
Okay. Okay, sir. Okay.
As of now, that's fine, good. At this
Okay.
primary phase, you develop this is the prototype, right? That's
Yeah. Yeah.
okay, fine. But later on, whenever you will be think about this prototype in the form of applications, at that time you have to think about the many of the parameters or the criteria.
Sure. Sure, sir. Sure, sir.
Okay. Okay. Thank you,
Yes.
ma'am.
Thank you, sir.
Thank you for the presentation, ma'am.
Yeah. Thank you, ma'am.
The next presenter is Arun Jana, and the paper title is Oil Fatty Acid Measurement System for the Blended Groundnut Oil. Arun Jana is a present or not? Okay. So we are moving our next presenter, Abhilash, and the paper title is Online Label Refinement for Weekly Semi-Supervised Semantic Vehicle Passing using CNN and Transformer.
Hello, madam. Good afternoon, everyone.
Abhilash here.
Yeah, Abhilash is not here. We are the other co-authors of the same paper.
Okay, so you will be presenting, right?
Yes, yes.
Okay, no problem.
Okay. Yes, let me just share my screen. Okay, so good afternoon, everyone. So today we are here to represent the online label refinement for vehicle parsing. Yeah. Okay. So the authors are Abhilash S.K., Venu Nukula, Karthikesh, and Bhargav Kumanami. So we will be going through the contents of having a small introduction of the company, overall the speakers and motivation of our project, and the architecture which we have designed. And then we go for the training details and dataset details. And later on, we will be going to the experiments which we have conducted and the ablation study which we have done on this paper and the future works of it. So company introduction. So Path Partner is a basically as recently as member of KPIT. So it is basically in the R&D product engineering and the R&D specialist, which helps in clients to produce and develop the technological solutions. So Path Partner is basically focus expertise on embedded operating systems, low level processors, architectures, deep learning, radar, image technologies, and multimedia. So and it also works on the next gen technology and to give solutions to the customers on the edge platforms, edge devices. So when coming to the authors, Abhilash SK is a senior technical lead at KPIT. So his main focuses on AI, ADAS, serverless analytics systems, building unilogist agnostic computer vision frameworks. And Venu Nukula is a software engineer at Path Partner. So his current work focuses on AI-based automotive surveillance systems, developing AI-based tools with using graphical user interfaces and computer measured models, developing and deploying it on the hardware. So Karthikeyan is a software engineer at Patpata Technology. So his work focuses on developing AI models, deployment of the development of computer vision models on different various platforms, and on deploying it onto the edge devices and developing of different architectures. And Bhargav Kumar Nami is also a software engineer at Patpata Technologies. So his works focuses on developing of OpenCV and DL based models and deploying it onto the hardware. So speakers, so we will be representing, so we will be have two speakers. One is me, myself, Karthikesh, and other will be the Venu Madhav Nukula. So let's head into the OLRVP, like our architectures. So motivation basically is based on part level segmentation. Or part segmentation or pixel wise segmentation is one of the leading edge segmentation architecture, because it gives a pixel level information about all of the objects. So many researchers have implemented many of the architectures on this part segmentation. Why? Because it is giving a high level information of each of the parts of an object. And application of semantic segmentation focuses on object level analysis and understanding. Object analysis in the sense, if we take a person as an object or a car as an object, so we will be getting individual details in depth of the each parts. Let's say if you have a person, we will be having detailed information of the head, torso, body, legs, hands, and everything. So when it comes to the car, we'll be having mirrors, front door, back door. So all those informations we will be getting from the pixel level segmentation. So next is vehicle auto assessment. So when it comes to the vehicle auto assessment, why it goes for a vehicle auto assessment is because it solves the problem of any damaged parts in an auto vehicle. We can easily, like let's say if the left mirror or some left bulb is been crashed. So when we give it to the model, so what it going to happen is we will segment the part of the region. So when we segment the part of region, and if we visualize that corresponding part, it will be easy for to analyze which part has been damaged. And next is AR VR based task or gaming aspect. So when it comes to the motivation, so as I said, so auto assessment of vehicles to identify the damages or missing parts in a vehicle. And next comes the part level visualization of prototypes. Like basically in the production level, what will be so in the production level, we have to see each and individual parts of a vehicle to make sure that each and everything is perfect. So this part segmentation will help in the production level. So, and also in self-driving cars for visual feed of surrounding vehicles to get information of the surrounding vehicles, uh, whether any other vehicles are there in moving around. And even if a parking slot, when it comes to the parking slot also, if there are any vehicles, and if the even if you want to check when we are parking our vehicle, and if any mirror is touching, so we can directly get to know that the other mirror is visible to us, so that we will be getting a notification or some kind of information, so that we'll be going parking the vehicle in a respective slot. And the challenges with respect to the data set is because the data set is exclusively for task for vehicle parsing or less in number. Basically the vehicle parsing data sets are very less, and whatever we have data set which we have taken DSMLR car part segmentation data set, that is very less. So problem of overfitting. So since the data set is very less, even if we train for like some large number of epochs, or the overfitting might occur during the training. And next is the label noises, like the noises in the ground truth or might occur when we go for training. Next, our architecture attempts to solve the problems with these the following methods. So one is the famous CE2P architecture, which is basically for the part segmentation. So we have modified that to have a semantic boundaries and a part segmentation both. So semantic boundaries in the sense we will be smoothing the boundaries of the whatever the parts which have been detected. Next is label refinement strategies, which we have used to in our training strategy, so that it will learn through the noises. And next is, and we have a generic and robust framework, and we have experimented our model with a different backbone. We have CNN variants and as well as a transformer variants. So next is, so we our OLR VP model, if we give this as input, and let this be the ground truth. So we have the CNN output, which is almost matches with the ground truth, and we have a transformer output matches with the ground truth. And these are the color codes for the each of the parts. Okay, next moving ahead to the OLRVP architecture. Okay, so OLRVP architecture, if we give an input image, first step what we do is we'll be going for the image processing. Image processing, we will be doing transformation of resizing the image, input image, applying affine transformation, and normalizing the input data. So the next step which we're going for is for the backbone. So wherein it is backbone is used for the feature extraction. So in the backbone we have CNN variant and as well as the transformer variants. So we are in the backbones, we have modified the architecture of the backbone in such a way that it gives us 4 outputs. So in out of those 4 outputs, the 4 outputs are always a sequential. So the output of one will be the input of the other. So at the end of the last output, we will be having the last output will be fed into the PSP module. So the PSP module is basically the pyramid scene parsing module. The pyramid scene parsing module is nothing but basically that architecture is basically meant for the segmentation, which gives high level feature extraction for the semantic segmentation. Since part segmentation is also part of the semantic segmentation, the PSP module will help us to give the features for each of the parts. So the PSP module, the output of the PSP module will be telling that the where the part is located, the high level feature of where the part or each parts has been located. So that output and one of the backbone output will be fed to the decoder module. So the decoder module, what it just it would fine tune the feature extraction to the particular layer. Let's say the PSP module tells that this part of the region is a door. So the decoder module takes that input and the layer 1 output, and it will make sure that the door has been properly cropped in its output. So next is the edge module. The edge module, why we use it is to fine tune the whatever the predictions which we got. So edge module takes the inputs from all the other remaining 3 outputs from the backbone, and it will give the edges of the car. The edges may not be 100% accurate, but why we use the edge module is because to fine tune the predicted parsing module. So if you see here, so what will be the output is we will be having very fine-tuned segmentation. So the segmentation, the layer, the boundaries will be very smooth. So the output of the edge module and the decoder module, we will compress it. So that fusion module output parsing will be our final parsing, wherein we will be having the smoothened the boundaries. Okay, next comes the label refinement strategy. So in our label refinement strategy, what we are using is we will be training the model for certain number of time.
Sorry for
And
the
after,
interruption.
sorry, yeah.
Yeah, but sir, only 1 minute left for the presentation.
Okay, sure. So during the training, so we'll be having, we'll be saving the model, like it will iterate through certain number of epochs, and after certain number of epochs, we'll start the label refinement by taking the output of the certain number of epoch, and we will apply moving average onto its output, and recursively the output of the previous moving average will be fed it as in next model input. So similarly, the cycle goes on. So we have limited the cycles to 6. Cycle 0 to cycle 6. Over the period of iteration, the label noises, it will the model tries to learn from the label noises, and it will smoothen the edges. So the next part will be taken care by Venunukula, the data set.
Okay. So currently in this in the existing work, we have limited set of datasets. So we have used GSMLR car part segmentation dataset, which consists of 19 classes, including background. So around we have very limited number of images. We have 500 images overall for 400 images for training and 100 for testing. And the annotation format we have, the author has used, or the dataset author has been used here is COCO format. Moving on to the training details. So we have restricted our model with our input resolution size of 473 cross 473 and learning rate to 70 to the power of -3, batches 64. And the loss functions we have used here is binary binary cross entropy loss and softmax loss along with divergence loss. Below the image shows that instances per category. Since we have 18 classes, for example, back bumper, back glass, back left door, back left right, and so on. So we have 18 classes for the number of
Hello.
images instances per category.
Hello. Sir,
Yes, yes, sir.
you are running out of time. We just go to conclusion.
Just give me a minute. We'll just press to the results and all. We'll close this part. Just a minute, sir. Can you go to, yes. So here we have trained our model with various of backbones, where we have chosen different CNN architectures and different transformer architectures, in which we are highlighting the best models in CNN and transformers. Here we are using metrics as PA, MA, and MIOU. PA is nothing but pixel accuracy. Accuracy, I mean, the percentage of pixels that are accurately classified in an image. The definition of PA. And moving on to the MIOU, MIOU is the intersection of the predicted mask with the ground truth mask. The percentage of intersection with the predicted mask with the ground truth mask. So if you see here, our MSCAN L architecture is beating MSCAN L architecture in transformers and CNN Reset 101 in CNN architecture. These two are our best architectures in CNN and transformer. Can you go to the next slide, Karthik? Yeah. So here we are providing the qualitative results. So the first row consists of the input images. The second row is the ground truth mask provided by the dataset. The third row is the CNN, the CNN model, which has been predicted with the CNN model. The fourth row is with the transformer architecture. Move on to the next slide. Yes, here we are providing ablation studies with two different sets. One is model interpretability, one is MIOU versus params. So model interpretability is nothing but how well our model is understanding the regions. For example, by looking into the which aspect it is providing, it is as a left mirror or left door. So if you see here, by looking in, for example, here we are providing some 4 samples, the front door. So the front door region, it is predicting by looking into the right aspect, the front bumper. It is looking into this front portion and it is predicting as a front bumper. This proves that our model has been perfectly learned all the aspects and we have trained. Can you move to the next slide? Just close it. Yes. So here are the some few references that we have used for our problem statement. Thank you.
Okay. Thank you, sir.
So any queries or any questions on this?
No, sir. Actually, the work is too lengthy, right? It is too difficult, right? So as of now, we don't have any questions, right? Okay. Thank you, sir.
Yeah, thank you.
Presenter is at Balirao, and the paper title is a point of care device for measurement of vital parameters.
Hello, good afternoon, ma'am. Hello, good afternoon, ma'am. Good afternoon, sir. Am I audible?
Yes, sir. You are audible. Please share your screen.
Thank you. So the title of our study or research is basically to develop a point of care device for measurement and analysis of vital parameters. So basic idea or motivation behind our research is, so as you know, whenever a patient goes to a hospital or to be precise, I would say any multi-specialty hospital, the most common advice that is given to them is basically to get done with all the tests like ECG, blood pressure, blood sugar, etc. And as far as in particular ECG is concerned, the complete setup of that ECG is quite bulky, and basically it comes with a 12 lead set, and all those 12 leads are placed on human body at different locations, and then we get 12 different waves for ECG, and then doctor tells their conclusion. So what our aim is to basically develop a reliable, economical, and a portable low form factor device which can easily measure ECG and related parameters. So as far as our methodology is concerned, in phase one, this is our prototype phase. The architecture, as you can see, is ESP32 is the major microcontroller which we have used. It is interfaced with a LCD screen for a display purpose. AD8232 is the sensor used by us. Secondly, the AD8232 sensor is used for ECG. And secondly, we have used this MLX90614 sensor for temperature. So the device which we are trying to make is also incorporating like contactless body temperature. Also, it has provided with 2 buttons for interrupt purpose, and it has a like power controller and a main button and a battery. So moving on in the phase 2, so this was just the prototype phase. Then in the phase 2, when we were actually making, like we wanted to make a proper full-fledged product, so we upgraded our hardware, and what we did was, instead of using an AD8232 sensor for ECG, we used some Maxim sensors which are medically graded and can be used in hospitals as well for ECG. The major advantage of these Maxim sensors was that they have built-in analog front end and also have filtering capabilities. So the ECG data which we were getting through these sensors was actually more refined and more clear. So major microcontroller we used in this phase was STM32. ECG and PPG sensor was used from Maxim 32675. Similar temperature sensor MLX90614 was used by us. A power management IC and a battery. Additionally, we have also interfaced a Bluetooth module in this in order to perform data acquisition and to transfer it to a mobile or any other web application. So these are our results in phase 1. What we have done is we have simply created a web app in which the data could be collected through the sensors, and ECG wave could be plot along with body temperature and heart rate calculation. However, as you can see in our phase 2, the ECG wave in our phase 2 like more better as compared to our phase 1. And this is the mobile UI which we have developed for data acquisition from the sensors and to display. As far as our algorithm is concerned for heart rate calculation, it's very simple. It's a very simple 4-step algorithm. First, we record a ECG for a specific duration of time. Let's assume it's for T seconds. Then what we do is, when we get that complete wave, we just take into consideration what is the maximum and minimum value of the peaks or the waveforms which we are getting, and we just calculate the difference between them. So that difference is what we are calling a threshold value. Then as we have that complete ECG wave, we are counting the number of times that QRS wave complex is crossing that particular threshold value. And let's assume that count we have received as K. So the simple formula we have developed for heart rate calculation is K into 60 by T, which gives us heart rate in BPM. So in order to conclude, as you can see in the images, this is the image here. The black box was the device developed by us in phase 1, which has the capabilities of ECG and body temperature. However, a more advanced version of this was in our phase 2, which was not only able to measure ECG, but also PPG, heart rate, and body temperature as well. So the features of our POC device are basically, it is portable, it is economical, easy to use, and it also has remote connectivity. So and as far as our use cases or applications are concerned, basically we want to deploy this product to our ASHA workers, who are basically the nurses working in rural areas, government hospitals. We could just easily hand over this complete setup to them rather than moving that bulky setup of ECG. Also, it is economical in monitoring patients in general wards, because general wards usually don't have these kinds of facilities. Also, it is readily available for home use, and practo services and remote consultation with doctors could also be easily established. So in order to give you a simple analogy, traditionally when glucometers were not available in market, we used to go and give our blood sample, and blood sugar report used to be available with us within few hours. But now, as glucometers are available readily with everyone, so even in at home we could find our blood sugar easily. So similarly, what we aim is that at every household they must have these short portable devices for ECG, so that they could easily get their ECG and related parameters at home itself. And as far as our future work is concerned, we need to deploy some machine learning algorithms for ECG analysis, whether to also give some accurate predictions whether the ECG is normal and in which part is there any particular blockage. And also we need to aim to develop some algorithms, as we have already be able to perform successful data acquisition for ECG and PPG. We basically also want to develop some non-invasive method which incorporates both ECG and PPG together to determine blood pressure. And also we also developed a basically camera module for medical imaging, like ear canal, nose canal, or throat passage. And basically, and then all these database could be collected and a proper patient history could be stored easily. So thank you everyone for giving me time and patient listening.
Yes, sir. Hello.
Hello. Yes, sir.
Yes, sir. So your future work, I mean, you expecting the future work that is for your develop prototype for ECC.
Yes.
Right? So in that case, you want to implement the some algorithms, and as you mentioned, the machine learning algorithm. So
yes, sir.
In that case, you have to think about that additional costs of your systems, because you know the machine learning algorithms need some computing processing power.
Yes. So let me clarify you on that part. So that could be done in basically two ways. Either we could deploy them directly on the backend on our apps, or the microcontroller which we have used, STM32. And in particular, that model number is F303RET6. So that particular microcontroller itself is capable that we could directly deploy ML algorithms in that hardware itself. So so you know, in that cost only we could do, like without any giving any additional cost, we could directly deploy our ML algorithms in that hardware as well.
Yes, and in that case, what you do, you can do it. You can just observe the threshold value. If it will be above that one, then only generate the alert, and the rest of things that will be omitted or deducted.
Yes, yes. So basically,
that
you
will
are
be also work as a filtering options, right? And which will reduce the data storage. I mean, data requirements.
Yes. So basically, you are suggesting like an alert system, right?
Yes. See, unnecessary why we need to store the, I mean, suppose at this moment we measure ECC, we have a report, right? We are storing it.
Okay,
right? But that report is the normal one. It is not like any kind of
abnormality,
severe kind of, right? So instead of storing it, you just skip it, right? Remove it, right?
Okay.
So in that case, we do not require additional storage space, right? And it will store it only those data which will be deducted by the some serious kind of the actions required, right?
Yes, sir. Correct.
So that can be stored in the form of patient history also.
Yes, yes, correct. And I don't know about any government plans yet, but I think if government is planning to launch any health card like similar to Aadhaar card, then this data could also be like easily integrated. So actually, this is the device which has been made and fabricated by us. So it's like so small, easy to carry anywhere, capable of measuring ECG, and you just have to connect these leads to our chest.
And one more thing, you have to also think about that the accuracy of your result.
Yes, that's why we have not. Yes, so actually our current accuracy is 75 to 80%,
right?
But we are still trying to improve it. The major drawback we are having in that ML part is the data set for Indian population. Like particularly for Indian population is not available everywhere. So we are having tie-ups in 3 to 4 hospitals in our city. So what we go, we manually go there, and through doctor's permission, we collect data from there, and we are building our own data set for this. So currently our accuracy is around 77%, but in future 5 to 6 months, we could take it up to 90%. And we will be soon incorporating that part as well in our further work in coming months, in upcoming months.
Okay, fine.
Thank you, sir.
Okay, thank you. So there is a Arun Jana is a present, so we consider them. So paper title is the oil fatty acid measurement system for blended groundnut oil. Hello, sir.
Yes, yes, I'm sharing my screen first.
Okay, sir.
Is it visible?
Yes, sir, it is visible.
Okay. Actually, my presentation is, first of all, good afternoon, everybody who was present offline and online. Myself, Dr. Arun Jana from SEDAC, Kolkata. My research topics is that oil fatty acid measurement system. Basically, it is system development for the blending percentage, for the identification of blending percentage of groundnut oil. So as you know that today's challenging issue is that oil blended oil is not pure oil is not available in market. Either it is blended or it is adulterated. So fatty acid content is a major prime parameter to identify the quality of whether it is blended or pure or it is adulterated. This is the very important parameter. That is this research main objective of this research is that to develop a objective based system, not subjective, objective based system, and portable, so that very easily it easily it can be used and for identify the whether blended or adulterated oil, edible oil can be identified. So fatty acid content is mainly basically combination of mustaric acid, palmitic acid, stearic acid, oleic acid, linoleic acid, and linolenic acid. These properties, all acid character is measured by the standard today's standard technical instrument is basically chromatography, either gas chromatography or liquid chromatography. This is measured by that instrument, and this component is measured. So this is basically very as you know, the chromatographic instrument, gas, either gas chromatography or liquid chromatography, these are the very costly and high manpower is required to train the to run the system, and also time consuming for each sample preparation, also highly complicated. So this is the basically our motivation to develop fatty acid content measurement instrument, so easily and objectively user friendly instrument. So this is the main target of this project. And the basic main scope of this project is groundnut oil and palm oil. Initially, we have started only this identification of groundnut oil, because groundnut oil is a very costly oil, but it is blended with, in market, it is blended with either palm oil or sesame oil. First, we have started with the groundnut oil to find out the adulteration or whether it is blended or not. So this instrument development is major challenging things is that under this instrument, this is the sensor based instrument. So sensor selection is the another challenging issue. And for that, we have through literature survey, it has been we found that mainly mainly acid component responsible compounds are the 2,4-decadinal hexane, all the volatile component. These are the chemicals we have selected for sensor. Each chemical has been 10 microliter of each chemical has been pipetted out in the sample container, and corresponding. So a lot of sensors we have procured from the market, metal oxide based semiconductor sensor, and each sensor individually exposed to the chemical, and out of that only 8 sensors we have chosen. And this is the basically sensor response to when we expose to the sample, while sample is exposed to the pure chemical. And based on the selectivity, we have selected 8 sensors. This is the sensor array. We have this is fabricated in our lab, and contain this array. These are the list of sensors finally responding to the groundnut oil. And this is this photograph is showing the laboratory based development. And under after this development, this is the odor handling delivery system, means how VOC, volatile organic compound of oil, goes to the sensor array. These are the steps, development step. And we have used in this system, we have used a magnetic star, and starter also is used because of uniform heating. Because without heating, while volatile of oil sample will not be released. So at least 50 to 60 degrees centigrade is required. So that using temperature, we have used the halogen bulb to increase the temperature, and also magnetic stir is used to stir the sample so that uniform heating oil is uniformly heated. And say this is the actual methodology how oil sample is tested in an instrument. 30 ml sample has been taken in a container, and 120 second heated for 120 seconds to raise the 60 degrees centigrade, and headspace time is 120 seconds, and also magnetic stir continuously on and purging is 120 seconds. This is the sample details where manually we have sample blended with groundnut and palm oil. So total number of sample we have prepared 115 sample. The sample is provided by KVK Akola. And after the clustering, we found that after getting the signal from the sensor, it is found that all are clustered separately. So it indicates that we can predict the whether groundnut and palm oil, how much percentage is adulterated to some extent. Not 100%, it cannot be said, but to some extent we can predict the this instrument, how much it is blended, how much percentage is blended with the groundnut oil. And for that case, in system instrument, one model has been correlation model has been fitted from sensor data signal and along with the gas chromatographic result. Once it is model is trained, then automatically it will be predicted within few seconds whether how much percentage is blended. These are the result. I'm not getting into the result part. That only finally the training data sets usually just before handing. Now system is basically working, and before handing the system, we got the found the for unknown sample around 95%, more than 95% accuracy is there. This is the photograph of software to execute to run the system. Different facilities is there under this software, and this is our complete device along with software. This has been installed and deployed at KVK Akola. Akola is a Maharashtra district, where groundnut factory is there. Oil extraction unit is also there. This is all, sir. Thank you. Thank you, ma'am.
Yeah, thank you, sir.
Hello, am I audible, ma'am?
Yes, sir, you are audible.
Yes, yes, please. Due to
Yes.
network issue, I was
Yes.
disconnected.
Yeah, yeah. Sir, any question?
No, ma'am.
Arun?
Okay, fine. Now,
Okay, okay, okay.
yes,
Thank you,
thank you.
Arun, for the presentation.
Okay. Okay. Thank you, ma'am.
So all the sessions are done, all the presentation. Yeah, thank you so much for all authors for the great and excellent presentation in this session. And also to all our participants for being a part of this international conference.
Yeah, thank you, ma'am.
Yeah, thank you.
Hello.
Yeah, thank you. I hope this session
Hello.
was informative. Yeah, I hope this session was informative enough. On behalf of whole team, thank you for the support during this version and the previous 6th version. We will be happy to have you in the 8th version in 2024. All the presenter would be getting the digital certificate through the mail within 2 working days. Further, all the paper have already forwarded to the stranger, and the publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM. And last, I would like to thank our session chair for chairing the session. Sir, here is the token of appreciation on behalf of whole SMARTCOM and the team of Global Knowledge Research Foundation.
Thank you, ma'am.
Thank you. At the end of the session, I will like to request to all please turn on the camera. Quick snapshot of this virtual conference. Okay, thank you and best of luck for the future. Stay safe, take care.
Thank you.